We're going to begin discussing topics in Chapter 1. We're going to skip ahead to Section 1, 2 in your Smith text. And in that section, they start talking about counting. Now, early counting dates back, probably before any evidence that exists in prehistory. But we do have examples of ancient counting in the form of things we call counting sticks. Here's an example of an ancient counting stick that was dug up from ancient Central Africa. This is the Shango bone, I guess is what it's called, but it dates back to 20,000 years ago, and you can see somebody here was tallying marks on this bone, and maybe they were counting the number of kills over the seasons that they hunted down, or something like that. But it's obviously a simple form of counting, and possibly even a little more complicated than that. It's possible that some grouping is occurring here. You can see that you can see in some of these locations on here. There's certainly like different groups. Maybe these are seasonal groups or something, or annual groups, or possibly they are placeholders and higher order terms. It's hard to say exactly what was going on here, but at the very least, it's obvious that some form of counting was occurring. Now, as societies became more complex and people started moving into agricultural communities and then into towns and cities, it because of bureaucratic needs and economic needs, the need to keep track of money and transactions and trade, a more systematic form of counting developed. The ancient Sumerians in the 3rd millennial BC, they've developed writing, and what they would do is they'd have a stylus, like a piece of wood, that they would press into clay and make marks, and these marks then they could use, of course, like I just mentioned, in writing, but also they started using them to keep track of a counting system they used. And our first example of this that we have, although it's possible that these sorts of ideas existed long before this, and certainly in some sort of verbal sense, if not in writing. But this is one of our first instances that we have in the historic record of written mathematic counting systems. This is from the third millennium. Third millennium BC, and it's a Sumerian system, and it's a base 60 system. We call a base 60 system a system that uses essentially 60 different, well, actually 59 different characters to represent the first 59 values of counting. And as you can see them represented over here on the right, when you get to 59, then it's similar to in our system when we have a base 10 system. When we get to 9, then 10 we start repeating again, and they would do the same sort of thing with this sort of system. So oddly enough, for them, 10 is really 60, the way they would count. So they had a different symbol for the first 59 numbers while they were counting. And one of the reasons they did this, a base 60 system, is probably because they had a lot of geometry in their mathematics, using circles and angles. And so it was 60 was a more natural way of looking at the separation of things. Like, for example, if you think of a circle, you can divide it into 60 segments. So, or multiples of 60, like 60 times 6 is 360, like we have with our circles, or 360 degrees. So this is probably why they used a base 60 system. And of course, the Sumerians passed this on to the Babylonians, and they used the same system. Now the Egyptians used a system more closely related to our base 10 system. Let me see if I paste this in here. So here's an example of the Egyptians system. So they used a system where they would count to 9, and then once they got to 9, then they would have a 10, just like we have a 10. And they would go 11, 12, 13, 14, 15, so on and so forth. And when they got to 19, they would go to 20. And by the time they got to 90, then they had a new set of symbols for. So you had a set of symbols that represented each of these increases in order, from the ones to the tens to the hundreds to the thousands and so on and so forth. And one of the reasons they did that, because they were pretty exacting in their building methods. They actually also had fractions too, which we'll talk about later, probably later in this chapter. So you can see how they put their numbers together. Now we put our numbers so that the biggest order term is on the left. Well, in their case, their biggest order term is on the right. So this would be the ones. The 8 represents the ones column. The 2 is in the tens. And for us, the 3 is in the hundreds. And the 1 is in the thousands. Well, theirs is the opposite. Their ones is here. And they end up with the thousands over here. And so they just stack these together. So you can see this 2 dash line is the 8. And then the next symbol here is the 2 symbol, or like 28, and then the 300 here is represented by this third symbol right here, and then the final symbol over here on the left is over here on the right, I mean, is 1,000. So 1,328. Okay, so when we count from 1 to wherever, the system we used is derived from a what we call a Hindu Arabic system, and it has evolved over the years. Paste another picture here. Here's a table that shows evolution of this system. So here at the 11th century AD, based on ideas from the Sanskrit representation of our numbers, we then advanced to a system by 1522, which looks pretty close to our modern number system. Now notice over here at 10, what you have going on. In some cases, you just have like a little dot. And that's because at this point, with these sorts of numbers, we didn't have 0 in here. You started at 1 and you continued to count. And when you got to 10, really what you have is a placeholder. And that placeholder evolved into the number 10, which is a 1 followed by a 0. But originally it wasn't like that. Okay, so this brings us up to the beginning of section 1.1.2 in our textbook. And when we start counting at 1 and continue on, so when we start counting at 1, 2, 3, 4, 5, so on and so forth, up to however high we want to count, we call these our natural number system, or natural numbers. And again, with the natural numbers, 0 is not actually considered a number. It's more or less just a placeholder. Every time you get to 10 and you have to spin over to another, the next decade of numbers, you use it as like a place counter. All right, sometime in the around the 7th century BC, a fellow by the name of Brahma. Okay, in the 7th century BC, fellow by the name of Brahmagupta came up actually with rules for using 0 as a number in our counting system. And this is kind of a natural idea to most of you, but at the time, this wasn't. Everybody just thought this was nuts, didn't make any sense. But if you're going to start using 0 in the counting system, then you have to have mathematics that describe how it interacts with the other numbers. For example, what happens when you add 0 to 1? What happens when you add 0 to itself? What happens when you take 0 and you divide it by a number? And all these sorts of things have to be worked out and thought out, and they all have to be consistent. And here's an image of artist rendition of what this fellow might look like. So he was a mathematician and an astronomer, probably an astrologer too, I would guess, back then. But anyways, he wrote a book, the Brahma Futus Hanta. I probably really butchered that, but and in this he wrote down the rules for, among other things, formalizing how to use 0 in our mathematics. So now we have 0 added to our number system, and we can count starting at 0, and we can use 0 in our mathematics. And when we have systems like this, we call these whole numbers now. So we started at natural numbers, now we have whole numbers. And that's where we're going to start our class, learning how to perform operations on natural and whole numbers to start with. And I'm going to end the video here.